Hello everyone, today I am going to walk you through how to create SSL certificates and how to generate a trust store, and I will also explain why each step matters. Well, certificates are something we work with all the time in enterprise environments, especially when we need secure communication for applications, whether it's HTTPS connections or Java applications talking to APIs securely. In this demo, I will show you how to create self-signed certificates which are great for development or testing. But remember, in production environments, certificates are usually issued by a certificate authority, or we call it CA, which is a trusted organization that validates your identity and ensures that communication is secure. Now let's start with the why. Why SSL and certificates are so important. SSL encrypts the data between the client and the server so no one can intercept it. They assure clients that they are connecting to the real server, not a fake one. In Java, applications use a trust store to keep track of which certificates they trust. Well, self-signed certificates are great for internal testing or learning purpose only. CA-signed certificates are required for production where browsers and the systems need to verify authenticity. Before jumping into commands, let's clarify a few key terms. Private key. This is your secret key. It proves ownership of your certificate. If it is leaked, your certificate can be misused. So keep it safe and never share with anyone or display it. CSR. Certificate signing request. Think of this as a formal request for a certificate. It contains your identity details like your organization name, domain name, and email, etc. But it does not include the private key. You send the CSR to CA for signing, or you can self-sign it for testing purpose only. Next, certificate. This is your public proof. It's what tells the world I am who say I am. It can be self-signed for development or testing purpose only, and CA signed for production. Then trust store. In Java, a trust store is a special file that holds the certificates your application trusts. So, when your application connects to another service using HTTPS, it checks the server certificate against the trust store to make sure it's safe. Let's begin with the demo. First, we will create a directory to keep all our certificates file in one place. Let's go to your server. So here inside OPT, I will create a directory called certs, mkdir certs. cd to this certs directory. This folder will store our CSR, private key, and certificates. Now let's generate our CSR using OpenSSL. Alright, we will keep all our certificate files in one central location, that is /opt certs. This makes it easier to stay organized and also simplifies mounting certificates later if required. Now that we are in our certs folder, let's generate the CSR using OpenSSL. I have kept all the commands here in this file. Let me explain this one by one. First command is OpenSSL request command. So this command will create two files. One is private key and another one is CSR file. The private key is extremely sensitive. It proves ownership of your certificate. So never share it with anyone or upload it anywhere in the public. The CSR file, the certificate signing request file, contains your organization and domain details. This is what you send for signing either to certificate authority CA or for self-signing in your internal or test environment. But before we can actually run that OpenSSL command, we need a file, configuration file, the .cnf file. This contains all the identity details like your country, organization name, and domain. I already have my real configuration file on my system. This one. But I am not going to show that here because it includes actual domain names and internal email addresses. Instead, I will walk you through a safe demo version so you can see the structure without exposing any sensitive data. So here is what a sample.cnf file looks like. This one. The sample.cnf file uses demo values here, but it's structured exactly the same as a real one. Now notice subject alternative names. This one, or subject alt name section. This part is very important. It lists all the domain names that should be valid under the certificate. If you skip this part, browser or APIs will often show errors like certificate not valid or hostname mismatch. So always include sans even for internal or test environments. Let me walk you through with each section means. The request. The request section defines general request settings like the size of key size 2048 bits, message digest SHA-256, and which section holds the identity info. So this one, required distinguished name. So the required distinguished name section defines who the certificate is for. Here C stands for country, ST stands for state or province, L for locality, O for organization, OU for organization unit, CN for common name, usually your domain name. Email address, contact email for certificate. Finally, the request extension and alternate name section define the subject alternative names. Basically, any additional domain names that should be valid under the same certificate. For example, here we have included both demo.example.com and www.demo.example.com. And that is our configuration file. This small piece is what allows OpenSSL to automatically fill in all the correct details when generating the CSR. Now let's go ahead and run the command. Copy the OpenSSL command and paste it in your terminal on the server where you are generating certificates. Paste it and hit enter. So here space is not required after RSA. And one more quick note before we move forward. When you run the OpenSSL CSR generation command, this one, it may ask you set a passphrase for your private key. If the certificate is going to be used in any automation system such as Jenkins pipeline, backend services, or containers, or in the Kubernetes, when you cannot manually enter a passphrase, you can skip this entirely by adding a -notes flag. So this tells OpenSSL no DES encryption, meaning your private key won't be passphrase or password protected, which is important for automation. But remember, that also means you must store it securely with proper file permissions. Okay, hit enter. Once the command finishes, we can check the files generated. So we have two new files. One is ending with .key and another one is .csr. .key, this is our private key, and CSR, our certificate signing request. The CSR is now ready to be used, either sent to certificate authority for signing or self-signed for the testing purpose. So we will be doing self-signed for our today's demo. Once we have our CSR, the next step is to self-sign it to produce X509 certificate. So this certificate can now be used for our Java application, web server, or API service to enable secure encrypted HTTPS communication. So our next command is Cert Signing. So here let's break down this what this command does. -REQ tells OpenSSL that we are using this certificate signing request, REQ request. -sign key /students.key uses a private key to self-sign the certificate. -out /students.crt defines the output file for the signed certificate. -day 730 sets the certificate's validity period for 2 years. -extensions and extension file, this con file. So earlier also I mentioned, ensures the certificate includes subject alternative name for the configuration file. This is very important for the browsers and the API to trust it correctly. After running this, let's copy this command and go to the server, paste it. After running this, we will have a new file called shstudents.crt, this one. That is our actual certificate ready to be imported in our application or Truststore. Hit enter. After running the OpenSSL self-signing command, you will see a new file called shstudents.crt. This is the signed certificate. I'm not showing the full command output here because it displays actual domain details, and as a best practice, we don't expose those publicly. Next, let's talk about what we do with that certificate, especially how we make Java trust it. In Java, there is a term called Truststore. A Truststore is simply a file usually named certs or ending by .jks that contains the list of certificates Java considers trustworthy when making SSL connections. Here is what happens behind the scene. When a Java application connects to the server over HTTPS, it checks the server certificate against the Truststore. If the certificate isn't found or isn't trusted, the connection will fail with an SSL handshake error. So by importing our self-signed certificate into our Truststore, we are telling Java, hey, this certificate is safe, you can trust it. Now let's go back to our command. So this command uses Java's built-in Keytool utility to manage certificates. So here -import flag adds our certificates into a Truststore, and -alias gives it a friendly name so we can identify it later, and -keystore this internal truststore.jks specifies the Truststore file. It can be a new one or an existing one you are updating. So once you run it, let's copy this. Run this command. It will ask you for a password. Remember this password. Re-enter. Trust this certificate, type yes. That's it. Java will now trust the certificate whenever your application connects using HTTPS. If we do ls here, internal truststore.jks file being created. So far we have created and connected all the key pieces: the private key, your proof of ownership, the CSR, your formal certificate request, and this CRT. It's a self-signed certificate in our case, but it will be a signed certificate. What identifies your application to others. And finally, this internal truststore.jks, the list of certificates Java considers safe. With these in place, your application can now securely communicate over HTTPS even in a self-signed or internal setup. Now let's validate our new certificates. First we will check the expiry date of our certificate. I have all the commands handy with me. So copy this command. So this tells us when a certificate becomes valid and when it will expire. Always verify this, especially before deploying to production. Okay. Today itself we have created. It will be expiring in 2027 for 2 years. It is valid. Next, let's validate our private key. This is the command OpenSSL RSA -in -check. This is the command to validate our private key. So this confirms that the private key is valid and correctly formatted. So I won't show you the output here for safety reasons. It can reveal sensitive details about our key. So well, this is the command. Okay, now let's validate our Truststore. So to validate Truststore, we have this command Keytool. So this command lists the certificate details stored inside our Truststore. So we can confirm that our self-signed certificate was successfully imported. So it will ask you for password which you created that time. Not the cert file, only cert. Enter the password. So by using Keytool -list -v Keystore internal truststore.jks and aliases sh students cert, using this command we can validate our Truststore. So this command lists the certificate details stored inside our Truststore. So we can confirm that our self-signed certificate was successfully imported. Once this is done, our Truststore is ready to be used by our Java application. Now let me show you the most important part, how to use your SSL certificates inside a Spring Boot application. Since we already have our Spring Boot application and our certificates ready, let's walk through how to apply the SSL certificate and a Truststore in our Spring Boot project. Like in our SCH Students API project, I already have my Spring Boot API project ready with me. So we will configure Spring Boot to use our self-signed certificate, the .crt file and the .key files by creating a Keystore that Spring Boot can understand. Spring Boot doesn't take .crt and .key files directly. It needs either a JKS file, which is the traditional Java Keystore format, or a PKCS #12 file. We call it .p12 file. Let me show you. So this is command to generate the .p12 file. So which is newer, more universal format. Now let me explain in simple and technical language what is PKCS #12 means. So technically PKCS #12 is a binary format that stores both your certificate and the private key together, kind of like a secure envelope. In simple terms, it's a container file that holds everything Java needs to enable HTTPS securely. Okay, now next step is to convert your .crt and .key files into a p12 file. For that we will need to run this command. Copy this command, go to your server and here run it. So it will create, if I do ls, so it has created sh students.p12 file. Now you might wonder, what is this password for? It is for it's the password that protects your Keystore. When Java loads this .p12 file, it will ask for this password to verify that the file hasn't been tampered with. So next step is to update your Spring Boot application. So inside your Spring Boot project, inside src main resources, this application.properties file is available. So in this properties file, we will need to add this section to enable HTTPS. So here server.ssl enable true, yes, we are going to enable it. Then server.ssl.keystore type keystore hyphen type is PKCS 12. Then our Keystore is class path keystore.p12 file, and here this name of or alias used is sh-students. So we can validate from here. So the alias used here is, or name used is sh-students. So we will be using the same name. So sh-students. Then server.ssl.keystore password. So Keystore password we used as change it. You can provide the password which you have used while creating this p12 file. The password is change it for me. And then server.ssl.key alias is sh-students. Okay. Next we need to provide the port, the new port which will be used when we are using the HTTP, we are hitting the HTTPS request. So this is although optional, but we will be including it. Instead of 8080, we will provide 8443. Okay, next step is to download this P12 and this JKS file from OPT certs location, from my server where we have generated it, from the server where we generated these. For me, that's in OPT certs. If I do refresh here, so I'm having P12 file available, also the JKS file. So using MobiXterm, so we can download directly from here. So let's place it in desktop, and the P12 file also download, keep it in desktop. Once done, okay, update your server port to server.port to 8443 and add these JVM options. These are needed to include the JKS. This is to include the Truststore, which is internal truststore.jks file, and the password for this internal truststore.jks. Next is to copy the .p12 and the .jks, so which I have downloaded in my desktop. This one is p12 and the JKS from my desktop, and paste it inside src main resources. So here paste. Next step is to rebuild and run our application. So for that, use mvn clean package. So here I am using -d skip test is equal to true. So this will skip running the Checoco test cases. Okay, once the build is success, so we will start the Spring Boot application using java-jar. Inside target folder, our newly created jar is available. Hit enter. So once this app is up, you will see the logs like Tomcat started on port 8443, which we have mentioned here. So started application, Tomcat started on port 8443. Then open your browser and hit the API. So go to student controller.java, copy this URL, open your browser. Yeah, here this localhost :8443. Then we have this request mapping as API v1 student, and the get mapping is at /student. So complete URL is API v1 student, then students. So when I hit enter, so it is showing me the details. Once we hit the URL in the browser, so we will see it is showing not secure. So that's expected because it's a self-signed certificate. So when we click on this not secure and the certificate details, so it will show us the certificate details. So under the general tab, you will see like details like CN, this common name, organization, valid dates, issues on, expires on all these dates. And under details section, you will find the extensions such as SAN, subject alternative name. Let me find it out. It should be under extension, certificate alternate name. All these details are available here. So next step is, okay, now let's implement the same setup in Docker. So we will copy both this .p12 and .jks into the container by adding copy instructions in our Docker file. So after this copying jar file, add instruction copy src main resources .p12 to the current location, which is /app, and again copy truststore.jks inside /app. And inside the application.properties file for server.ssl.keystore, just copy this line and comment it here for now and paste it here. So here provide the path as /app, means inside container it will search inside /app, this p12 file. The same way for truststore.jks, copy this here, and instead of class path just provide the path as /app/. So this is our complete Docker file, and here we are exposing the port instead of 3000 to 8443. Save it. Now build your image again. Let me terminate this one, and if I access it, it won't be accessible anymore. Okay, so start your Docker. So I have already installed Docker in my desktop. I'm just running it. So meantime, let me check Docker images. Okay, it's still running. Okay, it has started. If I do Docker images, so no image is running. So build an image, Docker build -t, give it a name sh students -ssl, and Docker file is available in my current location. So inside sh students, this Docker file is available. Inside sh students, this Docker file is available. So dot, enter. Once the image is built, let's check for the images, Docker images. Okay, so image being created. Now run the container, Docker run -p host port 8443, map it to container port 8443, and the image ID. Okay, here also you should see. So once the Tomcat starts on port 8443, visit the site again. So it should work exactly like before, but now it's fully containerized. So if you click on not secure and certificate details, it will show you the same details as earlier. So this is the manual way to deploy a secure Spring Boot application with cells and certificates, both in the server itself or using the containers. So in production, you will get the certificate signed by certificate authority, CA instead. So I will show you how to handle the same setup in Kubernetes using init container or sidecar container to mount and route certificates dynamically. And that's how you can create, validate, apply SSL certificates to a Spring Boot application both locally and in Docker. So if this helped you, please like, share and subscribe to motivate me to create more DevOps tutorials. So drop your questions or feedback in the comments. I would love to hear from you. Thank you.